Hi everybody, this is Matt. Today we're going to talk a little bit more about plasma cutting. We are continuing the series on Introduction to Plasma Cutting. And I figured before we actually start cutting and talk about cutting techniques, the important thing we need to talk about is laying out what is to be cut. And I'll give you a few tips and things that work good for me. You see we have two samples here. We've got aluminum and just mild steel sheet metal. And I want to talk a little bit about laying out techniques, just for the fact that I've learned the hard way about laying stuff out, and I just wanted to help anybody else out that hadn't quite figured out some of the tricks that I figured out. You could try them. If it works for you, great. If it don't, no big deal. You can just ignore me from now on. Alright, when I go to lay out aluminum, I like to use a red paint marker. Why red? Well, of course, my marker's going to be frozen up. You can see red. My marker froze up on me. I probably should have checked that. It is 18 degrees out here in West Virginia, so it's probably a little frozen. For steel, I like to use a yellow paint marker. It's just highly visible. Now, red does work on steel also. I can see the red, but when you put a shaded lens on, it is very hard to see that. Now, I know a lot of old timers, and I do too, still use a good old piece of soapstone to lay stuff out with. Soapstone shows up very nice on steel. Aluminum, it shows up pretty good too. Not as nice as on steel though, so I don't like to use it a lot. It's great for initial layout, I will say that. When I'm laying out a design, I'll do an initial layout, and then I'll do a final layout, and then I'll cut. My initial layout will be, get the design on there. See what it looks like. Is it good? Is it bad? Does it work? Does it not work? My final layout is when I've just finally said, okay, that is perfect. Don't move it. Don't want it changed. And I'll go in and I'll put it in a paint marker. The problem I've had with soapstone in the past is this. It is easy to remove. Now that's one thing I like about it for initial layout. I can draw a design, and we'll do like a stick figure. My drawings are very horrible, sorry. But draw a stick figure. Okay, that looks good. Not. I'm trying to cut out a horse. That's a person. Not so much. Let's change this around a little bit and draw something else. That's great. I can't do that with paint marker. Problem with this is I want to cut this thing out. Say I like my little stick figure. I think I'll cut him out. Well, I get my hand down here with the torch, get to cutting on this other leg. Oops, where'd my other leg go? So that's why I like to use a paint marker. Problem with a paint marker, especially for laying something out, is I know my yellow one will do this. Get to pushing it or push down a little too hard, and looky right there, it just drooled all over the place. They run horribly if you apply the wrong pressure or in the wrong direction. So that is a precaution with them. These are relatively cheap. These are just Forney brand at the local hardware store. Dime a dozen. I mean, they're not bad. They're really good markers. They have all kinds of colors from red to black to silver to green, yellow, orange. I like yellow or orange, but the orange is kind of the middle ground between the two. Obviously, if you mix these two colors, you do get orange. But the orange is visible, but not to the extent of the yellow. So that's my little tip. Another thing, for those of you that are not mathematically inclined, I recommend the Lufkin self-centering tape measure. There's other brands that also sell this. This is just what I can find readily available. The thing I like about this tape measure, and of course my light's going to be blocking me, you got two sets of numbers. The top number in black is the actual measurement. The bottom number is the halfway of the measurement. So if you go to the 3-inch mark and you look at the red numbers below 3 inch, it says 1.5. So it's a very good quick reference. I like that tape measure for that fact. It's a very good quick reference when you're laying something out quickly. Now another tool I like to use, and I use very often, is a good speed square. I like the Swanson speed square for the fact that it has these grooves. So if I want to draw a straight line on my table, and I need it to be 1 inch from the edge, I just line my soapstone up in the groove. It's 1 inch, and slide the square back and forth, and I have a 1 inch line on the edge of my table. And it's just a quick way to get a perfect 90 degree and a perfect 45. That's why I like this square. And I also like to use a combination square. You choose whatever one brand you want, but there's many different things you can use. But I like a speed square. It's just my go-to square when I want to square something up, draw a straight line. For drawing circles, I got a Family Dollar 50-cent compass. Took the little cheap pencil out of there and slapped a piece of soapstone in there, round soapstone. Find your center mark of your circle. Take a center punch, make a little divot, and you can draw a circle. Or you can draw a radius if you need to do a radius cut, like you're making a lifting lug, or you're making just a rounded part. So don't have to pay a whole lot. There's companies that sell attachments that go on plasma cutters that'll basically you do the same thing, center it up, and then your plasma torch will do the pivot where I have soapstone. But for freehand work, it's a lot easier to take and draw my circle, and then more challenging for me to do the cutting out by freehand. That's the way I do my work. There's many other type of layout tools, but this is just the basic ones I use. Throw this back in there. This is my layout tools that I keep on my bench almost all the time. Even though I have a nice toolbox for them to stay in, I can never keep them in their room. So again, soapstone is good for initial layout, or oxyacetylene. I will say this, there's not a lot of times that I'm dragging my knuckles across a kerf or dragging it across the lines to mess it up. So if you're just cutting pieces off to a certain length, yeah, I would just take a piece of soapstone. It shows up very nice, easy to remove if you change your measurements or change your mind. So that's what I recommend. But if you're doing something intricate, or like when we're doing our metal art, I'm running my hands all over this metal, gliding, trying to cut these lines that are usually pretty close together. I want something a little bit more permanent. Now, when we first started out, we did use Sharpies. I used a silver Sharpie. That's also a good thing for laying stuff out. The only problem I have with the silver Sharpie, it is not visible at all when under a shaded lens. So if you want something you can follow when you are under a shaded lens, yellow paint marker is the best thing. And if you're on aluminum, red paint marker. This yellow does not show up very good at all on the aluminum. Red, dark colors, black, anything like that, contrast colors is what you're looking for. So those are my tips for the day on laying stuff out. Now I want to shut up. I want to draw some designs on a piece of metal. We're actually going to have some plasma cutting going on and talk about that. Alright everybody, I had this piece of 4-inch flat stock, 1/4 inch thick. I had it in the chop saw. We're going to cut it off to length. I'm going to use this as a reinforcement brace for a goat milking stand I built. This stand is going to mount on the side of a aluminum livestock trailer, and this is going to go on the inside just to keep the bolts from wanting to pull through the aluminum wall of the trailer. And so I'm just going to cut this off to length. This is the whole piece will be the width of the stand, but on the inside. That'll just give it a little extra strength. I want to show you a few techniques for cutting this off in a straight line. One thing that's always a good idea to do is take a few dry runs. So if I was cutting this off free-handed, I like to connect a couple fingers and use those as a pivot point, where the only thing moving really is my fingers. Now you can do that on curved cuts. Straight cuts is a little harder unless you've got the long enough reach on them. But the best way to cut a straight line is with a straight edge of some kind. And you can see I have one set up here. All you'd have to do is just put this torch right against that straight edge and drag it. Now, we'll set this up. I'll show you how I like to set up a straight edge. I like to use a clamp of some kind to hold it down where it don't want to move. So generally I like to use my speed square. I have that little combination square on there, it works too. But I like to do something a little thicker where I have something to drag against. The only problem with this one is it's got this little lip, so it won't let me cut all the way across. But you can see this is easy just to hold one-handed and go. So we'll go ahead and use the speed square and we'll cut it off the rest of the way afterwards. So here we go. I got the machine set on 25 amps. It's 1/4 inch thick. We'll see how it does. I hit the end of my speed square. Best way to do it is either just flip it over or do it freehand. Now, I didn't quite line up perfectly, but that's okay. This is just going to be a support. We turn this over, we'll truly see what happened. We got a good bit of dross, but overall not too bad. I know you can't see this, but the cut lines are at about a 45-degree angle, which is about the right speed to be going. The dross, I just broke it off with my fingers. So, that's a clean cut, straight cut, even cut. So that's one way of doing things. There we go, I can show you this piece. Those cut lines are at about a 45-degree angle. That's about the right speed. I probably could have went a little slower, would have been a little better. But, all in all, it did fine. And I just broke that. See, it just comes right off. Well, I recommend a chisel for that. Now, the only thing you may need would be a flat disc if you were prepping this for welding. But, straight cut. That is one way of doing it. The other way would have been the standoff guide. I'm running the drag tips, that's why I couldn't use the standoff guide. Now, we'll demonstrate something else. Let's say that you don't have quite enough amperage for the piece of metal. We'll clamp that back down. I'll turn this down to my 19 amps that I use for sheet metal. We'll see what it does. Make sure you do not prop on the ground clamp. I'm keeping clear of it. That's what I want you to see. It was cutting it. It was doing a pretty good job actually cutting it with 19 amps. But if you go too fast, you'll have the metal blowing back up at you. And that's a telltale sign. And I've actually got a little bit of dross up on top of the cut. And you don't want dross on top. That means you go too fast. So, it comes out a little sloppy. It was just, like I said, metal coming back up at you. That's not what you want. Turn this back up a little bit. I'll show you what it looks like again. Alright, perfect. For those of you who do not have the best air supply, this is a perfect learning moment. My high frequency did not want to start. It did not want to, well, my arc did not want to initiate. So you turn the machine off first. Take the cap off. The electrode Okay, the electrode is about at the end of its life. But this is what I found. For those of you who have wet air, you know you have a moisture problem, which I know I have a moisture problem and I'm working on it right now. But if you know you have wet air, if that don't start, I like to just dry it on my coat sleeve. This electrode will actually draw moisture, build moisture up, and it'll keep it from wanting to start. That moisture will just interfere with everything, and it won't let it start the arc. All I do is take the cap off, dry the contact tip off, put the torch back together. We'll turn the machine on and we'll see what it does this time. I have not done anything else. Alright, we turn the machine back on, and let's go ahead and see what it does this time. I intentionally went too slow right here, just to give you a comparison to look at. The first cut was a little too fast. The beginning was about the right speed and then too fast. Now look at the too slow. You definitely want to maintain a correct speed to get the best cut, the most efficient cut, and the cleanest looking cut. And this is what says it all. On the left, you can see where I went too slow. On the right, too fast. It didn't even cut through. Correct speed does matter.